In this lesson on limits and continuity, we'll explore one-sided limits. Let's begin with the definition. First, we have our right-hand limit. So we say that the limit of f of x as x approaches c from the right, we denote this as x going to c with a plus sign above the c, so x approaches c from the right. We say that this limit is equal to L if the values of f of x are getting closer and closer to L as x comes into c from the right, meaning we're considering values of x that are greater than c. Graphically, this means that we're looking at x coming into c from the right, so values of x that are to the right are greater than c, and we say that this limit is equal to L if the values of f of x are getting closer and closer to L as x gets closer and closer to c from the right. And again, we denote this with this plus sign above our c. Similarly, we define the left-hand limit with x coming into c from the left, and we denote this with a minus sign above the c. And we say that this limit, this left-hand limit, is equal to m, or the limit as x goes to c from the left is equal to m, if the values of f of x are getting closer and closer to m as x comes into c from the left, meaning that the values of x we're considering are less than c. So we're looking at the values of f of x as x comes into c from the left, and again we denote this with this minus sign above our c. Finally, we have the following theorem, which says that a function f of x has overall limit L, so just limit L, as x approaches c, if the two one-sided limits are equal. So if we have both a left-hand and a right-hand limit, and if both of those limits are equal to L, then we say that the limit as x goes to c of f of x is equal to L. So let's take a look at an example. In our first example, I have here this function f of x graphed, and we're asked to evaluate several limits and values. First, we have the limit as x goes to 0 from the right of f of x. So I want to think about the values of f of x as x comes into 0 from the right, so bigger than 0. So for our function f of x, as x comes into 0 from the right, these values are getting closer and closer to 1. So this limit as x goes to 0 from the right is equal to 1. Now as x goes to 0 from the left, so coming in less than 0, our function f of x is not defined for x less than 0, so we do not have any values of f of x for x less than 0, so this limit does not exist since the domain of our function does not include x less than 0. Now for the overall limit x goes to 0 of f of x, remember for that limit to be equal to L, we would need both our right and left-hand limits to be equal to L. Our right and left-hand limits are not the same, so this limit does not exist. Finally, the value of f of 0, so what is the value of f of x when we plug in x equals 0? This closed circle here tells us that the value f of 0 is equal to 1. So for this same function, now we're asked to look at what happens around x equals 1. So as x comes into 1 from the right, so again, that means x is going to 1 for values bigger than x, we see that the value of f of x is getting closer and closer to 1. So our limit from the right is equal to 1. From the left, so values of x less than 1, the values of f of x are getting closer and closer to 0. Again here, I don't need to worry about this open circle. I'm not worried about f of 1. I just want to know what happens to the values of f of x as x gets closer and closer to 1 from the left. And those values are getting closer and closer to 0. So finally, our overall limit x goes to 1 of f of x, this limit does not exist because our two one-sided limits are not equal to one another. So in our previous limits, one of the one-sided limits existed but the other didn't. Here, they both exist, but they're not equal, so the limit as x goes to 1 of f of x does not exist. And finally, f of 1, what is the value of f of x when we plug in x equals 1? We see that that value is equal to 1 from that closed circle there. Continuing with this example, here we're looking at what happens as x is close to 2. As x comes into 2 from the right, so I'm looking at values of x greater than 2, So as x comes into 2 from the right, the values of my function are getting closer and closer to 1. Again, I don't need to worry about this open circle at x equals 2 because I'm not worried about f of 2. I just want to know what happens as x comes into 2 from the right. As x comes into 2 from the left, so now we're coming in from the other side, so the values of our function, again, the values of our function are just getting closer and closer to 1. So here, although we weren't asked for it, the limit as x goes to 2, so this overall limit as x goes to 2 of f of x, this limit is equal to 1. Because both of my one-sided limits are equal, they're equal to 1, so that tells me that the overall limit of the function as x goes to 2 of x is equal to 1. And finally, what is f of 2? F of 2 is the value of f of x when we plug in 2. This closed circle here at x equals 2 tells us that the value of f of 2 is equal to 2. And this will be an important point moving forward. So the limit as x goes to 2 of f of x is equal to 1, that is actually different from the value of the function. The value of the function is simply what we get when we plug in x equals 2, whereas the limits are looking at what happens as x gets closer and closer to 2 from each side. So one more with this function. So let's look at what happens as x goes to 3. So here, as x comes into 3 from the left, is our first one, so we're coming in from the left, the values of that function are getting closer and closer to 2 from the left. From the right, so x bigger than 3, again, the values of the function are getting closer and closer to 2. F of 3, the value of f of x when we plug in x equals 3, that is also equal to 2. And again, looking at these two one-sided limits, those both exist and are equal. So we can say that the overall limit as x goes to 3 of f of x is equal to 2.